All right, Bio 130 class. Well, welcome to class today. Today we're going to make the transition away from the bones and the joints and start talking about muscle. So this first one is called gross muscle anatomy. So let's dive into it. So we're going to first start out with talking about what's known as kind of the hierarchy of different structures and membranes within skeletal muscle. Okay, so we're going to first look at the muscle cells, and in muscle cells can also be called muscle fibers, and this is true of muscle cells and neurons or nerve cells, but not any other cells in the body can be known as fibers. So you can use that interchangeably. And then as far as this hierarchy goes, we're going to start with the large, the gross muscle, which we would think of as a muscle that we'd name, like the biceps brachii. Okay, so biceps brachii is our muscle. Okay, that is covered in a membrane called the epimysium. Okay, or epimysium. Okay, and then that muscle contains many fascicles. So that muscle is made up of a bunch of fascicles, and then each of those fascicles are covered by another membrane called the perimysium. Okay, and then each fascicle is made up of a bunch of muscle fibers and muscle cells. And each of those are covered by a membrane called the endomysium. Okay, so those are the three membrane layers. Okay, and then underneath the endomysium is the sarcolemma, and that's the specialized cell membrane of a muscle cell. Okay, and then each muscle fiber, so each muscle cell, is made up of a bunch of myofibrils. Okay, and then we keep going. Each myofibril is made up of many sarcomeres. And then finally, each sarcomere is made up of actin and myosin, which are protein fibers known as filaments. Okay, you could also say myofilaments. Myo means muscle. Okay, so that's kind of the hierarchy there. Let's take a look at that. So we kind of have a nice picture of it here. And so what I'd like you to do is pause for a second, see if you can fill in 1, 2, 3, which is the structures, and then ABC, which is the membranes. Okay, so take a second, pause, see if you can fill that in. All right, so let's start with 1. 1 is our large structure, which would be the muscle itself. That muscle is made up of a bunch of fascicles. All right, so we can see this is a fascicle, that's a fascicle, that's a fascicle, that's a fascicle. Okay, and then each fascicle is made up of a bunch of muscle cells or muscle fibers, right? So there's a muscle fiber, there's one, there's one, there's one, okay? And then we can see that those membranes that cover each, so the one that covers the muscle itself, A, is the epimysium. One that covers the fascicle, B, is the perimysium. And then one that covers each muscle cell is known as the endomysium. So all different connective tissue membranes that cover all these different layers. Okay, but we can go further, right? We started there with 3, so 3 was the fiber, so now we're back to 3, so there's our muscle fiber. Okay, again, it's covered by the endomysium, and then that muscle cell membrane is called the sarcolemma, so we see all that there. And then we see that each muscle fiber is made up of a bunch of these guys, which are called myofibrils. Okay, so bunches of those inside of each muscle cell. Okay, so that's number 4, so when we look at a myofibril, that's what it looks like. Each myofibril is made up of a bunch of sarcomeres, and that's one segment of a myofibril. Okay, and this is what a sarcomere looks like. Okay, and then that sarcomere is made up of a bunch of myofilaments, or we can just call them filaments, and those are proteins. Okay, and those proteins are known as the thick filament, which is myosin, and the thin filament, which is actin. Okay, actin, myosin, and myosin has these little heads on it, these little myosin heads. Okay, so that's the hierarchy. That's what it looks like. You definitely want to know that. All right, we'll just kind of recap here with those connective tissue membranes. The epimysium is the most external one. This covers the muscle, right? This is also known as fascia. Okay, connects to tendons, to bones. This is how this weaves right into a tendon, and that tendon weaves right into a bone, but really then weaves right into a connective tissue layer on bone, which is the periosteum. Okay, perimysium covers the fascicle. This is kind of the housing for blood vessels and nerves. Endomysium covers the muscle fiber itself. These are all loose connective tissue, mostly reticular fibers. And then all of these layers are interconnected, okay? If we were doing the lab in person, you would be dissecting a cat, and you would see that as you're going through the dissection, there is a lot of connective tissue. It's not like each muscle is distinct from each other muscle and each structure is distinct from each other structure. It's not that way. Everything is interconnected, and that's a big part of the dissection, is getting in there and separating out each piece. All right, so a couple different ways that muscles attach to bones, okay? And there's two general terms for the attachment sites, the origin and the insertion. The origin is a connection to the skeletal system, same as the insertion, okay? The origin is the less movable side, and it's usually proximal, whereas the insertion is the more movable side, and it's usually distal, okay? So that's the attachments. There's a couple different ways that muscles attach. The normal way is called the less likely way is the direct attachment, okay? And that's where the epimysium just attaches directly to bone or cartilage, no tendon, no aponeurosis. Okay, we'll talk about what an aponeurosis is here in a sec. So some examples of some muscles that do that. Two of our gluteal muscles do that, our gluteus medius and our gluteus minimus. They don't have tendons. See that right here? There's no tendon. It just goes right into the bone. Okay, but then we see on the other side that we do have tendons. So just on the origin there, we have a direct attachment. Okay, and then on the indirect, this is a more common one. The epimysium connects to connective tissue, which is a tendon, or an aponeurosis, and then it connects to bone. This is much more common. Stronger, can stretch, smaller, can cross over joints much easier, okay? This is what an aponeurosis is, a broad, flat structure like this, okay? Whereas a tendon is more band-like, solid and thick. Okay, another kind of version of something that is helpful to the muscular system is called a retinacula. And a retinacula's job is to hold tendons in place, okay? Because the problem is that the problem that the retinacula are helping us solve is that the shortest distance between 2 points is a straight line, right? And so think about your wrist, for example, okay? When you contract your muscles that squeeze your fingers down like this, right? If we didn't have anything holding the tendons down that go through your hand, then those tendons would come out here, right? They would make a straight line from here to here where that muscle starts, right? Way down at your elbow, okay? So instead we have a little retinacula holding down those tendons at multiple points in the wrist, in the hand, and the fingers, and those retinacula are doing just that. They're helping us hold down tendons. So we see some there. Yeah, they're definitely in here as well. They're not quite as pronounced in there. We have them in our ankle, same thing. Okay, so these are very similar to ligaments and they're very strong. Okay, so I'm going to switch over to YouTube to show you this video of what it looks like when you have a retinacula that's not working. Okay, so you're going to be looking at a lateral malleolus of an ankle. Okay, and you have a muscle that goes behind that lateral malleolus called the fibularis longus, and the tendon of that muscle goes back there. Okay, and it helps us with plantar flexion, helps us push our toes down. Okay, and the problem is when it does that, it kind of just pulleys, it acts like a pulley around, or the lateral malleolus, it kind of acts like a pulley for the tendon to go around, okay? And if there wasn't anything holding it down, it would slip up over the lateral malleolus and make a straight line between its insertion and its origin, okay? And so one common injury is called subluxing peroneal tendons or subluxing fibularis tendons. And you have when you have damage to that retinacula, that's what happens. So here's what it looks like. So there it is. See that little pop out? All right. See, that tendon should not be on top of the lateral malleolus. It puts it back in. Oh, that pops right back out. Puts it in, pops out. Yeah, so it shouldn't be doing that. It should be staying behind that lateral malleolus instead of doing that. I'm just going to do it again. Oh yeah. Doesn't look like it feels good. It can be quite painful of an injury there. Okay, so that's the subluxing fibularis. Yeah, so let's just kind of look at a few related things here to muscles. So we have in muscles these different groups of muscles that are called functional groups, and there's different ways that they can work. Synergists are groups of muscles that work together to produce the same movement. So we think of very common ones like the 4 quadriceps muscles all producing knee extension. And we have 3 hamstring muscles all producing knee flexion. Okay, that's one example, two examples. Okay, antagonists, it's an important term to know. Antagonists produce opposite motions. Okay, so they're good for so they're good for producing opposite motions, but then they also help us decelerate too. Okay, so for example, our biceps and our triceps, right? Biceps do this, triceps do this, so it's opposite. But when we throw a ball, we throw like that and we extend with our triceps, but then our biceps actually are the ones that slows us down and decelerates our elbow. Okay, same thing with our hamstrings in the back of our thigh and our quads in the front of our thigh. And then we have what's known as prime movers to a joint. Okay, this is the most important muscle, or the strongest muscle in a group of muscles all doing the same thing in a group of synergists. Okay, so when we think about hip extension, which is moving your hip back like that, right? That's hip extension when we go back. Okay, the strongest one out of that group that does that of this group of synergists is the gluteus maximus. Okay, but also our hamstrings do that, other muscles do that, but the most important one is gluteus maximus. Okay, then we have a muscle called type of muscle called a fixator, and instead of moving a joint, it actually just locks it into place so it doesn't move, and that's a very important function. So many of our back muscles are doing this all the time, but also a good example is of our gluteus medius muscle. Okay, I'm going to move this down a little bit. Our gluteus medius muscle is right here on the side of the lateral aspect of our hip, and it's an abductor, so it does this when it's not being a fixator. It lifts up, but in order for me to lift my left foot off the ground and keep my pelvis in place, I have to contract my gluteus medius. And so if that doesn't contract, what happens? I actually fall down like that. Okay, so instead of that abducting, it just holds me right in place. It's a fixator for my pelvis there. All right, another thing, kind of related concept here is something called muscle fascicle arrangement, right? So we said that muscles are made up of a bunch of fascicles, right? It's really just a bundle of muscle fibers together, okay? And the direction and the arrangement of these is very important for the function of the muscle, okay? So one example is called a circular fascicle arrangement. We find these in places like our eyes, right? Also sphincters around our anus, around our urinary tract, and our other tracts up in our digestive tract. Okay, facial muscles besides our eyes, other facial muscles do this as well. Okay, so circular, all those fascicles are in a little circle. Okay, we also have one called convergent, which is fan-shaped, right? So there's a wide origin, and then it kind of goes down into a small insertion. Okay, so locations we find this, think of your pectoralis major muscle, right? It's got a wide origin on your chest, and then it inserts in a small fashion into your humerus. Latissimus dorsi does the same thing. Okay, so another one is called pennate. A pennate arrangement is where you have this long central tendon, and then all of the muscle fibers come off of that tendon. Okay, and then underneath pennate, there's three different ways that this can work. Okay, it can be unipennate, which is a good example of that is our extensor digitorum longus. That's in our leg. You'll see that one soon. Okay, and then we have another one called bipennate, where we have just one central tendon and fibers coming off that in two directions. Unipennate is one direction. And then we have multipennate, which a good example of that is our deltoid muscle in our shoulder. Okay, so take a second, pause it, see if you can match up those three below. Okay, hopefully you did that. So B is our first one. That's unipennate. We can see all the muscle fibers coming off in just one direction. Okay, bipennate, you see here is A, rectus femoris, and then C is our deltoid. Okay, two more arrangements here. We have what's called parallel fascicle arrangement. Very long muscle, lots of shortening, but we don't get as much strength out of it, okay, because they're all pulling kind of in the same line, okay, and there's just less fibers contacting the tendon. One example of this is the sartorius muscle. That muscle that's the longest one in the body, goes all the way from your pelvis, wraps around down your hip. That one is parallel fascicle arrangement. And the crazy part about this one is some of those muscle fibers, about 20 to 25% of those muscle fibers, span the whole length of the muscle. So somebody's who's tall, their sartorius might be 2 to 2.5 feet long, right? So that means some of those muscle cells, the individual cells, are actually 2 feet long, right? That's an incredibly long cell. And then we have something that's similar to this, to parallel, but it's a little bit different because it has an enlarged central part. That's called fusiform, okay? And that's on biceps brachii is a good example of that. It gives us the ability to produce a little bit more force than parallel, but still not a ton. All right, guys, and it's just a brief one today, but that's it. We'll see you on Friday.